All right, here we go. Today we are working on review. Today we're focusing on derivatives. Remember, our exam that we're taking both in a couple days and in May is half calculator, half non-calculator. So not really half calculator. It's more like a third calculator, but they act like it's a half. Okay, so we got to know how to do both. They gave me a velocity equation. This is calculator. Find the acceleration of the particle at t equals 2. Is the speed of the particle increasing or decreasing at that time? Why or why not? Okay, so we use our calculator. We type in that equation. I want to make sure I'm in radians. The window they asked for, I think on the next question, I'm just going to go from 0 to 3, I think is all we need. So I'm just going to put it to 0 to 3 now. Cool, there's my graph. I don't know if that really does a whole lot for us, but it's there. Okay, they asked two questions. Question number 1 was, what is the acceleration? What am I going to do in my calculator to find acceleration? The derivative. This is a calculator question. Do not try to take this derivative by hand. Okay, if this were a free response, this would be a free response question. Okay, you would start off by saying, hey, if I want to find acceleration, v prime at 2. Okay, or you could just write a of 2. That's all you need to do is write that derivative. They know you have a calculator and that it's really easy in a calculator, so use it. So in my calculator, I'm going math 8, numerical derivative, dx. Inside the parentheses, I'm going to go alpha f4. I'm going to select y1. Or you could just type in that equation right there. At x is equal to 2. 1 point, how many decimals? 3 decimals on your test. You don't go 3 decimals, you're not getting points. 1.588 is my acceleration. Cool. Find the acceleration. That gave us 1 point. You got this down, you got 1 point. Then the second and third point would come from the second part of this. Is the speed of the particle increasing or decreasing at t equals 2? Why or why not? Thumbs up if you think the speed is increasing. Thumbs down if you think it's decreasing. I'm getting a little bit of both. What do I need to look at to talk about speeding up or slowing down? The velocity and the acceleration. We already got the acceleration. What we need to know, and you should have this written on your paper, is the velocity as well. So you need to find v of 2 as well. So to find velocity, that should be easy. I already got it typed in. Alpha f4, I'm going to just go y1 and say plug in 2. I'm plugging in 2 into that equation. I get negative 2.728. So based off of those two things, am I speeding up or am I slowing down? I'm slowing down. And my justification for this, the why or why not part, should be really easy. I'm slowing down because v of 2 and a of 2 have different signs. Done. That's it. That's all you need to write there for that justification. But it's very important that you write out what acceleration is and that you write out what velocity is. Then the justification can be easy. If they have different signs, you're slowing down. If they have the same sign, they're speeding up, whether they're both positive or both negative. That's the only answer you should write there. Don't try to get cute and create your own stuff. Okay, write that in. If I look at the graph here, what are we doing at 2? Here's 2 right there. We're below the x-axis. We're starting to head back towards 0. So it should make sense that I'm slowing down. But it's really easy if you just find those numbers. Questions on A? On letter B, it says find the times on the open interval from 0 to 3 when the particle changes directions. Justify. Show me with your fingers how many times does this thing change directions? Uno. Second, calculate. What am I going to calculate here? Calculate the zeros. I'm going to move this thing on my paper or on my screen to when I'm to the left of that 0. So I'm going to go to the left, hit enter, go to the right, hit enter a third time. Boom, that is my answer. 2.507. So T equals 2.507. That is my answer. Justify why my particle changed directions. What would my justification be? V of t, because they told me velocity, so I better say it in terms of velocity. Velocity changes signs. The best answers on justify normally are the shortest. Okay, velocity changes signs. I'm done. That is how I know a particle changes directions. Makes sense on what we're doing with that. That's an important, look at me. That's an important question. There's a decent chance that on the review you do in a couple days, it's going to have a calculator velocity motion question. Know how to do it. Cool. Put your name on your bell. I'm going to come get those. Get out your notes from yesterday. We're working on the backside. All right. Today we are working on derivatives. I would say today's focus is the basics of derivatives. That's going to be the main idea. Remember yesterday how I set up that paper and it was these nice big bubbles and it was very cute and easy to write in? I didn't do that today. It's way harder to write in this. I apologize. I was not very spatially aware when I designed this thing. All right. So when I write small, you too should write small. Product rule. When we talk about product rule, what is product rule? First times derivative of the second plus second derivative of the first. That is product rule. Quotient rule. Gotta write little guy. Quotient rule is low, D high, minus. Everybody say it out loud right now. Go. D low, all over. Low. Low squared. Good. Those are the two things. You know you need product rule or quotient rule if you see two variables. Okay? If you've got two x's or you've got two y's, that is when you need product or quotient rule. Okay? Keep that in mind. If you don't see two x's, then you don't need those two. Do the product rule and the quotient rule of those two problems. Go. Slade, talk me through product rule on this one. X squared first times. So times the derivative of the second. So the derivative of this guy right here is just e to the x. Good. Plus. Good. So he's going to rewrite all that. E to the x minus 1. Times 2x. Good. First derivative of the second plus second derivative of the first. That is product rule. Make sure you can do that one. Let's go down below. We're doing quotient rule. Quotient rule. Low D high minus high D low all over low. If we are doing low, obviously we're going to write x cubed. We're doing D high next. Marissa, what are we going to write for D high? 4x. That's the derivative of the top. And then it's minus high. So we're going to write that whole top part. 2x squared minus 1. D low. What's the derivative of the bottom going to be here, Allie? 3x squared. All over low. So on bottom, I'm going x cubed. Throw it in parentheses and then square it. The parentheses aren't going to make a huge difference here, but do it anyways every time. That's it. The one thing you got to be careful with, if you are simplifying this, don't forget that this negative distributes. Okay? So sometimes it's easier if you think, oh, this is negative 3x squared. Like if I wrote this the same concept, but I wrote negative 3x squared times 2x squared minus 1, sometimes it's a little bit easier to understand than the other version, because the other version, that negative is in front and the 3x squared is behind, and it just looks awkward, but just be able to handle that. Questions, product or quotient rule? Obviously super important. Let's split this next box down the middle here. Here's what I want you to do, because we struggled with this on our last test. You and your neighbor, I want you to just, in the next 30 seconds, brainstorm all of the ways that they could ask, find the derivative. Go. How many different ways can we say find the derivative? Obviously, it could say find the derivative. What else could it say? The limit as h approaches 0. That whole limit definition we did yesterday. Limit as h approaches 0 of f of x plus h minus f of x all over h. That's what we talked about yesterday. That's probably the least common version, but they could do it. And if they tell you that, then you're going to need to take the derivative. Wonderful. There's one. What else could we say? dy over dx. dy over dx is the same thing as saying find the derivative. F prime of x means find the derivative. about instantaneous rate of change? That just means find the derivative. Other ones. Yeah, anytime they would talk about something like velocity or acceleration or any of those things, we obviously understand. I'm not going to write them all down, but yeah, velocity in general. Y prime. This one we did on our last test and we struggled with it. Slope of tangent line. If it says the slope of a tangent line, that is a derivative. Okay? We could also just say the slope at a point. I'm guessing I still missed some things. Like that's a bunch of different ways of saying exactly the same thing, but there's probably something else out there. There's a lot of different things. Right now, if you take your test and you look at the question, you're like, what should I do? There's like a 90% chance that it probably involves taking a derivative since that's the majority of the things we learned. Make sense there? Just a quick reminder. So down here in the bottom of this box, just some quick reminders. If I gave you f of x is like 3 over x, and I'm asking you to take the derivative, okay? If your x is in the denominator, rewrite it. Okay, so 3 over x, or what if I said like 1 over x squared? Oh yeah, that is x to the negative 2. Don't forget to do that. Before you take a derivative, get x out of the denominator because you're not going to want to deal with it. Same thing if x is in a radical. You don't want to deal with something when x is in a radical. So if x is in a radical, what should you do instead? Rewrite as fraction exponents. Like, for example, if I gave you the cube root of x squared, what is the same thing as the cube root of x squared? X to the 2/3, because I squared it as well. So x to the 2/3. Yep, you're good. X to the 2/3. Make sense on those ideas? Nothing crazy there. I just want you to make sure that you don't forget about those things. All right, let's go to E and Ln. If I take the derivative of E, what is the derivative of E? What you see times the derivative of the exponent. It's what you see times the derivative of the exponent. What about the derivative of natural log? What is the derivative of natural log? 1 over the baby times the derivative of the baby. Baby prime? That's weird. Yeah, but I'm going to write it anyways. Do those two. Find the derivative of those two. Go. E to the 3x squared. We're finding dy dx, so let's find y prime. Same thing. If I'm finding the derivative. Aiden, what do you got? The derivative of e is e to the 3x squared. Good. Times the derivative of the exponent. The derivative of the exponent is 6x. Good. There's my derivative. Number 2 says y is equal to the natural log of 2x minus 3. If I'm taking the derivative of that, Kyson, what's that going to look like? 1 over 2x minus 3. Good. Times 2. Good. Okay, obviously we could take that 2 and put it up on top. Every once in a while they might do that as well. Just pay attention to it. Good there? Next is chain rule. How can you tell what is the big key if you need chain rule? Parentheses. If there's parentheses involved, there's a good chance that it is a chain rule question. Okay? If that we do it with something like this, f of g of x. If I'm taking the derivative of that function, remember, you take the derivative of the mama. You rewrite the baby. times the derivative of the baby. Every once in a while, they might give you a problem like that next one. What do you need on that next one? Chain rule, specifically 2 chains raised to the 5th power. Remember that 5 goes on the outside. Do it. Go. All right, here we go. We are taking the derivative, so we're going to start with the outside function. So, Taylor, what'd you write first here? Good. So she did the 5. What would your new exponent be? 4. Good. And then you were describing rewriting the inside. So sine of x squared minus 1. Good. She took the derivative of the mama. She rewrote the baby. Then from there, Natalie, what could I do from that point? Cosine. And then she rewrote x squared minus 1. And then she's going to take the derivative of this baby, which would be 2x. Sometimes it gets overwhelming. So when we go to that next step of, all right, I got to take the derivative of the baby, then if you have to, just stop. Like if Natalie got to this point right here where it was sine of x squared minus 1, just write it separately. You know how to take the derivative of that thing all day long. The derivative of sine is cosine. You rewrote the baby and then you times the derivative of the baby. Don't let it, just because it's inside of parentheses, play tricks with your brain. Okay? Going to the side and doing it again is sometimes helpful to my students. Questions there? Let's keep it rolling. Let's go down to motion. Okay? When we're talking about motion, lots of different things we can do with motion. Obviously, the first thing we always talk about is like S of t is position. What happens if I take the derivative of position? What do I get? Velocity. We just did that today. That's velocity. That's the derivative of position. If I take the derivative of velocity, what do I get? Acceleration. Those are things that we've done over and over again. I'm not worried about your skills on that thing. What if I just asked you, what is the speed of something? What does speed mean? It means velocity, but it's not velocity. It's the absolute value of velocity. If they ask about speed, it is the absolute value of velocity. So remember, velocity is like I'm going 20 miles per hour or negative 20 miles per hour. Negative 20 means you're going backwards. Speed, you're just going 20 no matter what. Okay, that's something you've forgotten. You might want to put a star by it because it's just something you forgot. Okay, what we did today in Bellworks, obviously important. Speeding up versus slowing down. If we are speeding up, what is going to be true? Same sign. So V of t and A of t, same signs. And then obviously if we're slowing down, what's going to be true? Opposite signs. V of t and A of t. And that's how you got to show it too. Just like we did in Bellwork today. You got to be the same sign or different signs. And you got to show what the actual values are, not just say, oh yeah, they were different signs. Questions there? We will do a ton more with motion second semester. But for right now, that's about it. The only other thing I would say is remember, how do you determine if you're moving left or down? Moving left, down, backwards. They use all of those different phrases. But all of those things, what would be true if I'm moving down, left, or backwards? Velocity is going to be negative. If your velocity is negative, you're moving back or down or left or backwards or any of those things. Everybody remember those concepts? All right, let's get to differentiable. All right, this is the big one on this one. Differentiable. What does differentiable mean? What has to be true if you're differentiable? Must be continuous. What other things are we looking for? No corner points. What's the other word for corner points? No corners or cusps. Yeah. No corners or cusps. We're looking for those things. We don't want them to happen. And what was the other place that you can't find a derivative? Verticals. Vertical tangents. Endpoints get kind of weird there. No vertical tangents. No vertical spots on your graph. Again, the majority of the time, it's corners and cusps. I would say like 90% of the time, it's going to be corners or cusps. All right. So this is the question a lot of you were trying to do yesterday on our limits review. We want to find, the directions are going to be something like find C and D that makes f of x differentiable. Those would be the directions. The top thing is a line. C and D are two constants. That's a line. The bottom thing is a parabola. Lines are continuous and parabolas are continuous and differentiable. The only worry is at 2. Remind yourself how you do this. So this was the tougher one when we did it. First thing we had to do was figure out when they were going to be continuous. How do I determine if two equations are continuous? Left, right, and middle. The good news is I really don't care about the middle because it's already equal to each other. So to make sure that they're continuous, I would take the two things and set them equal to each other. To make sure that they are differentiable, what would I need to do? To make sure they're differentiable, you need to take the two derivatives and make sure they're equal and set them equal to each other. So the two derivatives. What is the derivative of cx plus d if c and d are constants? It's just c because that's like 3x plus 4. What would the derivative of 3x plus 4 be? It'd be 3. What's the derivative of cx plus d? Oh, it's c. So c is going to be equal to the derivative of this bottom part. What would the derivative of that bottom part be? Minus c. Solve one of them. Okay, you're plugging in 2. So right now you could plug in 2. So it could be like 2c plus d equals 4 minus 2c. And over here I'd have c equals 4 minus c. Solve that thing. Take a second with your neighbor and go. I would pick this equation over here because it just has c's in it. So if I add c to both sides, I get 2c equals 4. So c is 2. Once I got that c, I could plug it in over here. If I plug in c over here, I'm going to get 4 plus d equals 4 minus 4. D is going to be equal to negative 4. Those are the two values I need to be continuous and differentiable. Continuous, set the two values equal to each other, find the limits. Differentiable, set the two derivatives equal to each other and find that. That's the toughest thing we're going to do today, obviously. Okay, trig derivatives. If we start off with sine, what is the derivative of sine going to get me? Cosine. If I take the derivative of cosine, what's the derivative of cosine going to get me? Negative sine. And if I took the derivative of negative sine, then I'm going to get negative cosine. Snapchat, negative Snapchat, it's your best friend. Don't forget about that guy. The other trig derivatives that you might have forgotten is like, what if I said f of x equals tangent? What is f prime of x going to be? The derivative of tangent is secant squared. You've forgotten that. You need to remember it. Okay? The other thing you've forgotten is like, f of x is secant. What is the derivative of secant going to get me? Oh, no one knows. The derivative of secant is secant tangent. Again, not as important, but they would ask you that. They will not ask you for the derivative of tangent of cotangent or cosecant or anything like that, but you need to know those. Okay? The other thing you need to know is your unit circle, at least this much. Okay? If you can remember that part of your unit circle, you're going to do fine. Okay, if you don't know that much, you need to go back and look at it a little bit more. But the first quadrant and the four main axes, you need that. Last question. Again, this was on our last test, and I got a lot of wrong answers. Average rate of change. We've done that a bunch. What does average rate of change mean? Slope, but more specifically, what kind of slope? Slope between 2 points. Like y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I had a lot of students try to take derivatives. Average rate of change does not mean derivative. Average rate of change means the slope between 2 points. And that's where you got to get to. Derivative